Hello, grade 9 students. How are you? This is Miss Manal. I'll be teaching you this year mathematics. And as you know, we are going to start by a quick revision for the things that you have learned already in grade 8 so that we will make a warm up before we start with our new lesson. So the objectives for our lesson are expanding polynomials, also simplifying, reducing polynomials, and we are going to remember together the remarkable identities that are used in expanding and in factorizing. First of all, let us remember together what's the meaning of algebraic expression. So an algebraic expression, it's a collection of letters and numbers together. They are organized in an operation using operations like addition, subtraction, multiplication, and division. The letters are numbers that are unknowns. They could be replaced by any value. And the numbers or the coefficients are multiplied by the letters, and if you replace the letter by any number, you should multiply it with the coefficient. So all in all, an algebraic expression, it's a combination of letters and numbers together. Let us take this example. If we have f of x equals 5x plus 2y times 3 minus 6. This is f of x. When I say f of x, means this is an algebraic expression of a variable x. So the variable is the letter x, where you can replace it by any number. E of a equals 4a squared minus 2a plus 7. E of a, it's an algebraic expression of the variable a. And every term in the algebraic expression is called a monomial. Now, what's the meaning of like terms? The like terms are terms that they have the same variable, but the variable should have the same power or exponent. They could have different coefficients, but they should have the same power. Let us take an example. If you look here, we have 2xy minus 8xy. They are called like terms. Why do we call them like terms? Because if you look at the variable x in both, they have the same power. And the variable y, it's also found in both, and they have the same power or the same exponent. So 2xy and minus 8xy, the variables are the same and of the same power. Also, a squared b c cubed and 10a squared b c cubed are like terms because the variable a, b, c in both, they have the same power. But if you look at 9x to the power 4 and 5x squared, they are not like terms because although I have the same variable, which is x, but they don't have the same exponent or the same power. Now, what's the meaning of numerical value of an algebraic expression? When I have an expression that contains letters, I can replace these letters or these variables or unknowns by a given value. So I could give, for example, let x now be 5. So every time you see x, you should replace it by the number 5. Like for example, f of x equal x squared minus 3x minus 5. We are replacing x by minus 1. So every time you see x, you should replace it by minus 1, and then you solve according to the order of operation that you already know. Now, how can we only add or subtract like monomials? So we've already learned what's the meaning of like monomials. So now we are going to learn how to add them or subtract them. So it's very easy. We only add or subtract the coefficients of the like terms. So we keep the variables with the exponents as they are, and then we add and subtract the coefficients. So first of all, we should remember together that if you are multiplying two same sign like plus times plus, it gives me plus. Minus times minus equals plus. What I'm trying to say that suppose I'm multiplying plus 2 times plus 2, it's plus 4. And if I'm multiplying minus 2 times minus 2, it's plus 4. So if you are multiplying same sign, you're going to get a positive. If you are multiplying different signs, you're going to get a negative. Like if you are multiplying plus 2 times minus 3, you will get minus 6. And if you are multiplying minus 7 times plus 2, you're going to get minus 14. So multiplying same sign gives me positive, multiplying different signs give me a negative number. Now if I'm multiplying two monomials, you multiply the signs together, the coefficients together, and the variables together. And if the variables they have the same if we have the same variable, then you keep it and you add the exponents. Of course, now you will understand everything when we start exercises. Now we have minus 2xy times 3x squared. As I told you, you start multiplying the signs. Minus times plus, it gives me minus. We multiply the coefficients. 2 times 3, it's 6. X times x squared. So here we have same variables. So we keep the x and we add the exponent. So we get x to the power 3. Y, we don't have anything to multiply the y by, so we keep it. So it's minus 6x to the power 3y. So here the trick is only to multiply the signs together, the coefficients together, and the variables together. Now we're going to talk about expanding, developing, and algebraic expression. Well, expanding, it's to get rid of the parentheses by multiplying. So when I want to get rid of the parentheses and we have a coefficient or we have any variable before the parentheses, we need to multiply. The rules are very easy, as you can see in number 1. If we have m, it could be coefficient, it could be a number, or it could be any variable. So what I have to do is to multiply m by every term in the parentheses. So I multiply m by a, which is ma, m by plus b, which is plus mb. What if I have minus in the middle? M times a, it's still plus times plus, so we get ma. M times b, here we have positive times negative, which is negative, so minus mb. What if I have before the parentheses another parenthesis? As you can see, it's very easy. Every term in the first parentheses, it should be multiplied by every term in the second parentheses. So m should be multiplied by a and b. Also, n should be multiplied by a and b. Here we go for the remarkable identities. The remarkable identities are special terms. Why they are special? Because their answers are direct. You can do them, you can write them directly without expanding all the steps needed. So if you have a plus b squared, the answer is directly a squared plus 2ab plus b squared. So square of the first number or the first term plus 2 times the first term multiplied by the second term, so 2 first second, plus square root of the second. So very easy, square the first, 2 times the first times the second, plus squaring of the second. This is very easy. This is, as I told you, it's a special expanding. And what if we have minus in the middle? The only change that we will have is minus 2ab, but we will keep plus b squared as it is. Now if we have a plus b into a minus b, so it's the product of a plus b and a minus b. It's directly, you can do it, a squared minus b squared. And now let us start practicing all the things that we have remember together. So I'm going to start by expanding and developing the following terms. We have minus into 2x plus 3. So the minus, which is outside the parentheses, it should be multiplied by every term in the parentheses. So I'm going to multiply first minus by 2x, then minus by plus 3. Minus times 2x, it's minus 2x. And minus times plus 3, it's minus 3. So we get minus 2x minus 3. Now we have 5 into 3x minus 1, so I'm going to multiply 5 by 3x, then 5 by minus 1. So 5 by 3x, we multiply the coefficients, 5 times 3, which is 15, and we keep the variable, which is 15x now we get. 5 times minus 1, so they are different signs, so it's minus 5. Now a times 2a, it's we need to multiply the variables here. So a times a, when we have the same variable, we keep it and we add the exponents. So in both exponents we have 1, so 2a squared plus a times 1, which is a. So every term outside the parentheses, it should be multiplied by every term inside the parentheses. X times 2x, or x cubed times 2x. Here we have the same variable, so we add the exponent. So we add 2, we will get 2x to the power 4 plus x to the power 3 times x squared. It's x to the power 5, so we add the exponent. Now x cubed times minus 1 is minus x cubed. So the final answer is as follows. Here we have minus 2y squared into 3y plus 5. So I'm going to multiply the signs first, the coefficients, and then the variables. Minus times plus, it's minus. 2 times 3, it's 6. And y squared times y, it's y to the power 3. So it's minus 6y to the power 3. Now I'm going to multiply minus 2y squared times 5. So minus times plus, it's minus. 2 times 5, it's 10. And y squared times nothing because we don't have any other variable, so we keep it as it is. Now here we have x minus 3 into x plus 1. So as I told you, every term in the first parenthesis should be multiplied by every term in the second parenthesis. And here we don't have anything special in these two parentheses because x minus 3, x plus 1, we can say that this is the remarkable identity x minus 3 into x plus 3, for example. So I'm going to multiply normally. X times x, it's x squared. X times plus 1, it's plus x. Minus 3 times x, it's minus 3x. And minus 3 times plus 1, it's minus 3. So we get x squared plus x minus 3x minus 3. Here, as you can see, we have like terms, right? Plus x and minus 3x, we call them like terms. So we need to group them together. So plus x minus 3x, what do? We add or subtract the coefficients of this variable. So we have plus 1 minus 3. If we have different signs, we put the sign of the biggest, which is minus, and then we subtract. So we get minus 2x. So the final answer is going to be as follows. The second one, 2a plus 1 into 3a minus 2, it's the same concept. So we are going to multiply every term of the first parentheses by every term in the second parentheses. So 2a times 3a, it's 6a squared. 2a times minus 2, it's minus 4a. Plus 1 times 3a, it's plus 3a. And plus 1 times minus 2, it's minus 2. Do we have any like terms? Yes, we have minus 4a and plus 3a. So they have different sign. So we put the sign of the biggest, which is minus, because 4 is bigger than 3. And we subtract. 4 minus 3, it's 1. So it's 1a. Here we go for the last one. Here we have to do every one alone. So 2x into 1 minus 3x will be alone, minus into 5 plus 4x alone, and minus into 2x minus 1 into x plus 3 alone. So here, 2x times 1, it's 2x. 2x times minus 3x, it's minus 6x squared. So you multiply them. Here I want you to pay attention to something. Every time you have a minus, you have, here, I will show you where. Here we have a minus, right? So you need to pay attention to put a minus, then you open a bracket here, as you can see. You open a bracket and you multiply everything inside. Why? Because here the minus will change the sign of every term inside the parentheses. Sorry. So as you can see here, minus will change the sign of every term in the parentheses. So it will become minus 2x squared plus 6x plus x plus 3. Now after doing this, we collect the like terms. So minus 6x squared and minus 2x squared are the same. 2x minus 4x minus 6x plus x are the same. Minus 5 and plus 3, they are the same. So you solve all the like terms together. Now I'm going to use the remarkable identities. So x plus 3 squared, it's the same as a plus b squared. So the answer is squaring the first plus 2 times first times second plus squaring the second. So squaring the first, it's x squared plus 2 times this first times the second, so 2 times x times 3, which is 6x, plus squaring the second, so squaring 3, which is 9. So the answer will be x squared plus 6x plus 9. Here we have 2x minus 1 squared, so it's the same thing, a squared minus 2ab plus b squared. So squaring the first, minus 2 times first times second, plus squaring the second. So 2x squared, it's 4x squared, minus 2 times 2x times 1, it's minus 4x, plus 1 squared, which is 1. Here we have a minus b into a plus b. It's squaring the first minus squaring the second. So squaring the first is 9x squared minus squaring the second, which is 2, so it's 4. In the last one, you're going to do every one alone. And as I always remind you, when you have here a minus, look what will happen. You will put the minus and open a bracket, because the minus here will change every term inside the parentheses. I advise you to stop the video to solve this alone, then check your answer at the end.